In this problem here, we're asked to solve this polynomial inequality, x cubed plus 2x squared minus 24x greater than or equal to 0. So we're tasked with that problem of solving this inequality. Now remember, to solve nonlinear inequalities, the first thing we need to do is have the inequality either greater than or less than 0. So everything needs to be combined together. And then for polynomials, we set it equal to 0. Figure out what values make it 0. So here we have the equation x cubed plus 2x squared minus 24x equals 0. And so we can pull out an x as a factor. Now when we do that, we're going to be left with an x squared plus 2x minus 24. So that x squared plus 2x minus 24 is of a format that we can factor. Right? So we look for things then that would multiply to be minus 24, add to be a positive 2, and it turns out the things that we need would be a plus 6 and a minus 4. Okay? So then that's equal to 0, and once we have it factored, we can very easily solve and get that there are 3 values that make this 0. Remember, those are the values where the graph could cross the x-axis. In other words, changing from being positive to negative. So that's why we find those values. Then we plot those values on a number line. Now I make those solid circles because the inequality was or equal to. And those are all values that make it 0, so that's why they're included. And then remember, what we do here is we need to pick a value then in each region. There's 4 regions here. Stuff below -6, between -6 and 0, between 0 and 4, and bigger than 4. Right? We need to find values, so we do that. So I might pick like -7, -1, 1, and maybe 5. Right? And then I just need to go through and check each one of those values, plug it into a calculator. If you use your table feature of your TI-83, TI-84 graphing calculators, you can very often speed this process up, save yourself a little bit of time. If not, just plug them in and compute them. So when I plug -7 in, I'm going to get -77. I'm going to get -77. Okay, and so therefore it's negative for that first region. And then we plug in -1 and evaluate it. And it turns out when you do that, you're going to get 25. And so it will be positive for the second region there. Then we plug 1 into our polynomial and compute it. It turns out to be -21, so we'll have a negative for that region. And then finally we do the last one as well. Plug in 5 into that polynomial, working out, we get 55. So it's positive in that region. Once we've completed the sign for each region, we just go back now and we look at the inequality. We want at the intervals where it's greater than or equal to. So in other words, where it was bigger than. And remember, we are including these endpoints. So -6 to 0, and from 4 onward to infinity. So we can write it down like this: the interval from -6 to 0, union the interval from 4 to infinity. Again, bracket on the 4, the 0 and the 6, because those are all included.